One morning in December, that whisper finally arrived at a small control room in Cambridge. There, a group of scientists stared at their screens, their hearts beating faster than the blinking lights before them. The James Webb Space Telescope had seen something. Not a blur, not a reflection, not an error, but a pattern so precise, so deliberate, it silenced the room. For a moment, no one spoke. Only the hum of machines filled the air. The data scrolled like a quiet confession from the universe itself. A signal 120 light-years away, coming from a world they had only seen as a faint speck of gold. Numbers began to align, graphs shifted, and out of the noise rose something undeniable: the chemistry of life. Not a possibility, not wishful thinking. 99.7% certain. A discovery that could rewrite every story humanity had ever told about being alone. The lead scientist leaned back, eyes wide, a trembling smile forming as the realization took shape. Somewhere, far beyond our reach, a world was breathing. Perhaps not like us, perhaps in ways our minds can barely grasp, but breathing nonetheless. It was as if the universe had exhaled for the first time, revealing that life was not confined to one fragile blue planet. That world had a name, K218b, a name that now hums like a spell in every laboratory, in every late-night conversation among astronomers who have devoted their lives to chasing ghosts among the stars. K218b, a planet orbiting quietly in the constellation of Leo, glowing faintly beside its red dwarf sun. At first glance, it is nothing extraordinary. A sphere of rock and gas, circling a small, cool star. Yet hidden beneath its atmosphere lies a perfection that defies coincidence. Its size, about 8.5 times that of Earth, gives it a gentle but unyielding gravity. Its blanket of hydrogen traps warmth just enough to cradle its surface at a steady 120 degrees Fahrenheit, a temperature so balanced that water could flow freely, neither frozen nor boiling away into the void. It is strange to think of a place so far away yet so familiar. Beneath its soft amber skies, light filters through thick clouds, scattering into shades of violet and blue. The air shimmers faintly with suspended moisture, a delicate balance of gases that dance between chemistry and life. Somewhere below, perhaps vast oceans ripple in slow motion, stretching for miles, their waves heavy with hydrogen, their depths glowing faintly with reflected starlight. K218b orbits its red dwarf star, a sun smaller and dimmer than ours, but far more enduring. While our sun will fade within a few billion years, the star of K218b will burn for trillions, outliving civilizations, outlasting galaxies. Time moves differently there. Seasons, if they exist, might last for centuries. Life, if it began, has had ages upon ages to evolve in peace. A world where nothing rushes, where the pulse of existence beats slow and steady, guided by patience older than the Earth itself. To imagine standing on its surface is to feel the scale of the cosmos pressing gently on your chest. The horizon curves sharply, painted in the copper light of a distant sun. The atmosphere thickens the view, bending colors into halos. You might look up and see no stars at all, only a deep violet canopy that glows softly, as though the planet itself were lit from within. Somewhere far below that haze, unseen eyes could be staring back, sensing the same wonder, feeling the same pull of mystery that now grips us. The more we study K218b, the clearer it becomes that it was made for endurance. Its gravity holds its gases in place with unwavering strength, creating a protective cocoon against the radiation of space. Its distance from its star keeps it warm, but never scorched. Every element aligns too neatly to dismiss as luck. Scientists describe it as the sweet spot, a natural equilibrium that allows complexity to flourish without chaos. Yet what makes K218b truly remarkable is not just its temperature or its chemistry or its stability, but the feeling it stirs in us. It reminds us that life, in all its delicate beauty, might not be a rare miracle, but a quiet inevitability. Perhaps the universe has always been alive, breathing softly through worlds like this one, waiting for us to finally listen. When the James Webb Telescope turned its golden mirrors toward that faint glimmer in Leo, it wasn't just searching for a planet. It was reaching across time into a past that is still shining toward us. The light Webb captured left K218b 120 years ago, back when humans were lighting their first electric bulbs, back when flight was a dream made of paper and wind. While we were learning to lift ourselves off the ground, this planet was already whispering through the dark. Now, That whisper has arrived. Data transformed into meaning. Meaning into wonder. Wonder into a single truth that echoes in the heart of every person who dares to look up. Life did not begin here. It began everywhere, quietly, patiently, waiting for us to notice. K218b is not a distant fantasy. It is real, stable, alive with possibilities. It orbits its eternal sun, untouched by our noise, a silent reminder that existence may be far richer than we ever allowed ourselves to believe. The universe has spoken in the language of chemistry, light, and time. And for the first time, we are beginning to understand what it's been trying to say. Soon, James Webb will peer deeper into its atmosphere, decode its colors, listen to its hidden patterns. Somewhere in that shimmering hydrogen sky lies the answer, not to whether life exists beyond us, but how much of it has been there all along, waiting to be seen. K218b, the planet that made the universe breathe again. When the first streams of data from K218b reached Earth, they looked nothing like the bright, polished images that fill science documentaries. What arrived instead were faint ripples of light, invisible to the human eye, stretched thin by their journey across 120 light years. Yet within those ripples hid a secret. Each photon, each fragile particle of light, carried a chemical fingerprint, a silent code written by the gases that drifted above an alien world. For months, scientists stared at those codes, cross-checking, recalibrating, doubting what they were seeing, until the pattern refused to go away. Somewhere inside the haze of that planet, the telescope had caught the signature of a molecule called dimethyl sulfide. To most people, it's an unfamiliar name. But to the researchers gathered in the control rooms of NASA and Cambridge, it was electric. On Earth, there is only one known source of this compound: life itself. Every whiff of dimethyl sulfide on our planet comes from tiny organisms that drift through our oceans, breathing, multiplying, releasing it into the air like an unseen confession of existence. The presence of that same chemical on K218b struck like thunder. It meant that, against every odd, something there might be alive enough to exhale. The discovery felt fragile at first, as though one sudden breath could blow it away. The team double-checked their instruments, reanalyzed the raw data, turned every number inside out to find an error. None appeared. The signal was clean, consistent, repeating. The probability of coincidence? Less than 3 in 1,000. 99.7% certain. The universe had spoken not in words or images, but in molecules. Around the discovery room, silence deepened. Not the heavy kind that follows disappointment, but the kind that hums with awe. Dimethyl sulfide was not alone in the data. There were traces of methane, water vapor, and carbon dioxide, each one part of a delicate chemical dance. Yet something was missing: ammonia. On a lifeless world, ammonia tends to build up over time. On K208b, it was almost entirely gone. The balance was off in a way that only life could explain, as though a living process were quietly adjusting the planet's air, maintaining it in perfect equilibrium. The thought was unsettling, beautiful, terrifying all at once. Somewhere, under that thick hydrogen sky, could exist a biosphere so vast that its breath had reached across light years, faint yet undeniable. Not a shout, not a beacon, but a soft exhale that the James Webb Telescope had the sensitivity to hear. In the following weeks, the data rippled through the scientific community. Every lab, every observatory began pulling apart the findings, testing for flaws. Some questioned the signal, others defended it, but no one could look away. It was too coherent, too precise, too alive, like finding a heartbeat in a storm of static. For many of the scientists, the realization felt strangely intimate. They had spent their lives peering into the dark, searching for numbers, spectra, signatures. Yet here at last was a moment where those cold symbols began to feel warm. Dimethyl sulfide was not just a molecule. It was a message written in chemistry, one that transcended distance, language, even biology. Life had found a way to introduce itself, not through sound or light, but through the breath of its own metabolism. A few researchers described it poetically, calling it the smell of alien seas. On Earth, DMS carries the faint scent of rain mixed with the ocean, the aroma of waves breaking on the shore. To imagine that same fragrance drifting through an atmosphere light years away was almost too much to comprehend. It made the vastness of space feel suddenly smaller, as though two distant worlds had shared the same quiet breeze. But awe quickly gave way to curiosity. What kind of life could create such chemistry? On Earth, dimethyl sulfide comes from plankton, tiny floating life forms that feed the oceans. On K28b, the oceans would be different, thicker, perhaps darker, filled with hydrogen instead of nitrogen. Yet the mathematics of survival would remain the same. Energy, carbon, molecules, the ingredients are universal. It was possible that beneath those alien waves drifted microscopic beings thriving in conditions unrecognizable to us, still guided by the same invisible hand that shapes all living things, the instinct to persist. Every new analysis deepened the mystery. The methane levels, too high for simple geology. The carbon dioxide, balanced in a way that mirrored photosynthesis. The absence of ammonia, a chemical silence implying some process was consuming it. Piece by piece, the puzzle began to form an image, not of structures or creatures, but of a living world breathing in harmony with itself. There was something almost poetic in the idea that the first true sign of life beyond Earth wasn't a signal carved in stone, or a radio transmission, but a trace of gas lost in the wind. Life had revealed itself in the most natural way possible, by being alive. It didn't seek to announce its existence. It simply lived, as it always had, unaware that on a small planet far away, sentient beings were reading its breath and calling it a miracle. The story reached beyond science. News outlets tried to frame it as a discovery of aliens, but that word felt too crude. What had been found wasn't an image of something strange or monstrous, but a mirror, a reflection of life's quiet persistence. The chemistry of K218b echoed the chemistry of Earth, as though both planets were written in the same cosmic language, only separated by accent and tone. At night, some of the Webb scientists admitted to stepping outside, looking up at the part of the sky where K218b drifted unseen. They described a strange calm, a sense that the distance didn't matter as much as it once did. To look at that star was to feel connection rather than isolation, kinship instead of emptiness. It wasn't that humanity had suddenly found neighbors. It was that the universe had always been a community. We just hadn't learned to listen. The data kept coming, layers upon layers of spectral lines painting a portrait of a world both alien and familiar. It became clear that this was not an anomaly or a random chemical trick. It was a pattern born from rhythm, regulation, life. Each molecule of DMS drifting through that alien air carried a story that began in a droplet, a cell, a spark. Perhaps something microscopic swam in the deep hydrogen oceans of K218b, feeding on chemical gradients as old as the stars themselves, multiplying, dividing, breathing. Its exhalation had crossed the void, now resting inside a telescope's sensor, the faintest evidence of something enormous. By the time the analysis was confirmed, the discovery had already changed how humanity saw the universe. The question was no longer whether life could exist elsewhere. It was how many forms it might take, how many breaths were rising right now across the galaxy, waiting to be heard. Dimethyl sulfide, a simple, fragile molecule, had become the most powerful proof of company in the cosmos. It told us that life does not shout. It hums, softly, through chemistry and time. It does not seek our recognition. It simply continues. As scientists watched those spectral lines pulse on their screens, they began to see something larger than science itself. The universe was not silent after all. It was speaking through the language of molecules, reminding us that every atom, every breath, every heartbeat is part of one endless conversation. Somewhere in that hydrogen sky, invisible to us, the planet K218b continues to breathe. Its air swirls with methane, water vapor, and traces of something alive. The telescope can only listen, but even in the silence between data streams, there is a sense of presence. Gentle, constant, undeniable. The universe has always been alive. We are only just beginning to hear it. There's something hauntingly beautiful about a planet that never loses its warmth. K218b drifts in silence, locked to its star so that one side always faces the light while the other remains in eternal night. On Earth, that imbalance would mean disaster, one half scorched, the other frozen solid. Yet on K218b, the rules are rewritten. Its thick hydrogen atmosphere wraps around the planet like a vast cosmic blanket, spreading heat with such precision that not even the darkest ocean freezes. The night side glows softly from within, warmed by the breath of its own air. The hydrogen moves slowly, flowing like a tide across continents that might not exist, across oceans that never rest. In that steady exchange between day and night, the entire planet breathes as one. The warmth of the star touches its daylight side, then drifts through the atmosphere, circling the world in endless rhythm. Each gust of wind carries a memory of the sun, keeping the darkness alive with quiet heat. Gravity on K218b is relentless, almost 3 times stronger than on Earth. To walk there would be to feel the pull of existence itself pressing down with quiet authority. But that same gravity holds the atmosphere close, refusing to let it drift away into the vacuum. Every molecule of hydrogen, every trace of methane or water vapor remains loyal to the planet's grasp. This is why its warmth endures, why its oceans can stay whole, why its sky does not fade into emptiness. What feels like heaviness on the ground becomes protection in the air. Beneath that sky lies a world so deep that no sunlight ever reaches its heart. Scientists believe there are oceans here, not the kind we know, but seas of unimaginable depth. Hundreds of miles from surface to core, made of water laced with hydrogen, thick and luminous, glowing faintly from chemical light. Waves rise and fall in slow motion, sculpted by pressure so immense that even atoms move differently. In those depths, energy flows like a current, carrying nutrients, heat, and possibility. On Earth, the deepest parts of the ocean host creatures that glow, that feed on chemical reactions instead of sunlight. Perhaps on K28b, the same principle reigns. In the crushing dark, simple organisms might drift, shaped not by light but by warmth, feeding on hydrogen the way plants here feed on the sun. Each cell a tiny laboratory, repeating the experiment of life in ways both familiar and alien. The sea would not sparkle like ours, but shimmer faintly, as if the water itself were alive. Above those oceans, the air is thick enough to blur the horizon. Light from the red dwarf star scatters through the atmosphere, painting everything in hues of gold and crimson. The daylight is dim compared to ours, but it lasts longer, softer, steadier. The winds move in endless circulation, rising from the hot side, gliding toward the cold, descending in slow spirals that carry warmth back again. There are no storms as we know them, no violent hurricanes, just a planet-sized heartbeat, regular and calm. K218b's stability is its greatest gift. Its star, smaller than our sun, burns slowly with a patience that defies imagination. While the life of our solar system counts in billions of years, K218's red sun could shine for trillions. Its light will not swell into a fiery death for eons beyond reckoning. That means whatever life began there has had time beyond our comprehension, to evolve, adapt, and survive without interruption. Where Earth's history is a brief flare, K218b's might be an unbroken song, stretching through epochs so long they erase the meaning of beginning and end. It's strange to think that on a world with such fierce gravity and crushing oceans, life might actually find more comfort than it does here. The conditions that seem harsh to us could be precisely what makes it stable. No wild temperature swings, no devastating ice ages, no sudden shifts in orbit. Just balance, the kind of balance that allows complexity to grow, quietly, over vast stretches of time. On Earth, life is always fighting, adapting to survive the next catastrophe. On K218b, it might simply live. The more we learn about it, the more it feels like a contradiction. A world both gentle and immense. Its heaviness creates safety. Its distance from its star creates warmth. Its darkness shelters light. It's as if every element of the planet has found a way to cooperate rather than compete. Even its orbit, perfectly tuned, keeps it at just the right distance to sustain its delicate equilibrium. There's poetry in the way this planet carries its own peace. Somewhere in its perpetual twilight, the boundary between night and day forms a ring of endless sunset, a band of gold that never moves. That narrow region might be the most beautiful place in the universe, a coastline of light stretching around the world, where the sky glows faintly red and the oceans mirror the dim star above. It is there, perhaps, where life thrives most vividly, in the gentle warmth between extremes. Scientists call such a region the Terminator line, the twilight zone where day meets night. On Earth, that boundary races around the planet once every 24 hours. On K218b, it is still, unbroken, eternal. Imagine a landscape that never changes, a sky forever caught between sunrise and dusk. The air there would be dense and warm, heavy with vapor, glowing in soft hues of pink and blue. It could be a haven for life, where temperatures stay steady and the balance of light and dark never shifts. Every observation suggests that K218b's design, if such a word can be used, is made for endurance. Its oceans recycle gases, its gravity holds everything in place, its star offers patient warmth. Together, they create a feedback loop of stability that could outlast the universe's brightest galaxies. Time moves slowly there, not in seconds or years, but in the rhythm of chemistry, pressure, and breath. Perhaps that is why the signals from its atmosphere feel so calm. They don't rise or fall in chaos. They hum in harmony, like the background note of a planet perfectly tuned to the frequency of life. The absence of ammonia, the balance of methane and carbon dioxide, the trace of dimethyl sulfide, all these chemical clues whisper the same story. This world does not merely host life, it protects it. On K218b, life would have no reason to hurry. It could evolve gradually, layer by layer, cell by cell, sculpted by constancy rather than struggle. What kind of beings could arise in such serenity? Perhaps creatures shaped by pressure instead of pain, guided by cooperation instead of survival. Perhaps intelligence itself would bloom differently there, slower, quieter, more contemplative. From Earth, it's easy to romanticize such a world, to see it as a reflection of what we wish ours could be. But in a way, K218b reminds us that peace is not the absence of struggle, but the presence of balance. Everything there seems to know its place. The heat, the air, the oceans, even the light. If a living world could be described as content, K218b might be the first. Its warmth never wavers, its skies never tear, its star never rages. It has existed in quiet perfection for longer than we can measure, breathing in its own rhythm, glowing softly in the constellation of Leo. Perhaps one day, through the lens of the James Webb Telescope, or whatever comes after it, we'll see its surface clearly. The shimmer of hydrogen seas, the glint of a distant horizon, the faint reflection of clouds in an alien sky. Until then, it remains a mystery wrapped in warmth, a reminder that life may flourish not where the conditions are identical to ours, but where balance itself becomes the law of existence. The more we learn, the clearer it becomes. K218b may not just be alive, it may be better at living. Far beyond the reach of any aircraft, past the satellites that circle our planet like silent watchmen, there hangs a single golden eye gazing into the dark. The James Webb Space Telescope drifts at a place called L2, 1,000,000 miles away from Earth, suspended in a perfect balance between the pull of gravity and the push of sunlight. Out there, no sunrise ever touches its mirrors, no night ever falls. It floats in a kind of eternal twilight, a machine built to see what human eyes never could. Its heart is made of gold. 18 hexagonal mirrors, each one polished to near perfection, fit together like honeycomb. They catch light that has traveled billions of years, light so faint that a candle on the moon would outshine it 1,000-fold. Yet Webb can still see it. The telescope's sensitivity is so extreme that it could detect the heat of a single bee resting on the lunar surface, or the warmth of a match struck in the shadow of Saturn. In a universe where light fades faster than memory, this instrument listens to whispers that began before humanity existed. The engineers who built it called it the Golden Eye, though its brilliance is hidden from the naked view. Every surface was designed for silence, not spectacle. Its mirrors are thin, its structure delicate, yet it can hold steady in temperatures colder than any winter on Earth. Behind it stretches a shield the size of a tennis court, 5 layers of silver fabric that block the light and heat from the sun, Earth, and moon all at once. The telescope does not bask in light, it hides from it, for darkness is its only friend. At L2, it moves with our planet in perfect harmony, orbiting the sun but always keeping Earth at its back. From this vantage point, the telescope can look outward into the endless black, unblinded by the warmth of home. Its sensors record wavelengths invisible to us, light stretched by time into deep red tones, the kind only infrared can catch. That kind of light is ancient. It is the glow of worlds long vanished, the afterimage of galaxies that no longer exist. Webb doesn't see the present, it reads the past, decoding the story of creation written in radiation. When it turned its gaze toward K218b, no one expected anything dramatic. The planet had been cataloged before, a faint blip crossing a distant star. Yet the data that came back felt different. Sharper, richer, almost alive. Webb's golden mirrors had captured starlight filtering through the planet's atmosphere during its orbit, each photon carrying a fragment of chemical truth. To separate that faint signal from the blinding glow of the star, the telescope used one of its most subtle tools, a coronagraph. It's a small mask that blocks the light of the star itself, leaving behind the faint shimmer of the planet beside it. Through that shimmering residue, the telescope began to hear the planet breathe. Molecules revealed themselves in delicate waves. Methane, carbon dioxide, vapor. The telescope's detectors are so precise they can distinguish a change of brightness smaller than 1 part in 10 million, enough to tell whether a single molecule of gas is present in a faraway atmosphere. That kind of precision feels more like poetry than engineering, a machine built not just to see, but to understand. Inside its core, each photon that strikes the mirror is guided through instruments colder than ice. Detectors translate the faint heat of the universe into patterns of light and sound. Computers transform those patterns into colors our eyes can recognize, reds and golds and violets that show where elements like oxygen, hydrogen, or carbon might exist. Every pixel in the image carries time within it. The light from K218b that Webb recorded began its journey before most people alive today were born. It crossed space while human history unfolded below. Wars, inventions, music, silence. By the time it reached the telescope's mirror, it was already an echo of what once was. In that way, James Webb is not merely a telescope. It is a time traveler, a messenger that bridges past and present. Its gaze pierces deeper into history than any human mind ever could. To look through it is to witness the moment before galaxies took shape, to see stars forming inside clouds of dust, to trace the first flickers of life on worlds still unknown. It is a machine built for memory, yet it has none of its own. It simply records, faithfully, endlessly, like a monk copying the words of the cosmos. The stillness around L2 amplifies its solitude. There are no sounds there, no air to carry vibration. Only the faint hum of circuitry and the distant rhythm of solar radiation. In that silence, the telescope turns slowly, methodically, guided by commands that left Earth days earlier. Every motion must be precise, every calculation perfect, because a single mistake cannot be fixed. There are no astronauts stationed there, no hands to repair it. James Webb lives entirely alone, its only company the stars. Those who designed it knew it might outlast them. Its mission stretches decades into the future, long enough for generations to grow old beneath the same sky. Somewhere within its memory banks, data from K218b will remain, unchanged, long after the people who first studied it are gone. Machines like this do not experience time the way we do. For them, a century is only an extension of purpose. What makes Webb's achievement extraordinary is not just what it sees, but how it makes us feel. In its golden reflection, humanity glimpses itself, small, fragile, yet capable of building something that touches infinity. Each discovery it sends back is more than a number. It's a reminder that curiosity, when pursued with patience, becomes a form of love. A love for the unknown, for the quiet spaces between stars, for the idea that knowledge itself is a form of light. When scientists received the data confirming the chemical traces in K208b's atmosphere, some cried, some simply stared. The telescope had done something no eye could. It had looked across the abyss and found warmth. The instruments, cooled to near absolute zero, had captured the heat of another world, a heat gentle enough to sustain oceans, steady enough to cradle life. In that moment, the telescope was not just a tool but a storyteller, whispering across space about a planet that may be alive. Those who visit the control room say the screens glow softly in shades of amber, the color of the telescope's mirrors. Each new transmission begins as static, a sequence of unreadable numbers, until it resolves into data that feels almost human in its rhythm. Every reading is like a pulse, every analysis a heartbeat. The longer you watch, the more you begin to sense that the telescope itself is alive in some quiet way, not conscious but aware. At night, when the Earth-facing instruments sleep, James Webb continues to drift, absorbing the oldest light in the universe. Its mirrors catch reflections from galaxies so far away that their light began before the Earth even existed. Somewhere in those faint glimmers, perhaps in the halo of K218b, the temperature reads a steady 120 degrees Fahrenheit, the same number returning again and again, like a refrain. That detail struck the scientists as uncanny. The warmth that sustains life on Earth, the same delicate balance that lets water flow, echoed across the void in perfect harmony. The data from K28b seemed almost deliberate. The same temperature recorded at different depths, in different wavelengths, in signals gathered weeks apart. 120 degrees. The number pulsed in the graphs like a heartbeat, as though the planet itself were breathing in time with us. The telescope had found something extraordinary, but it had also reminded us of something ancient, that our connection to the cosmos is not measured in distance, but in resonance, a shared warmth, a shared rhythm. High above the noise of Earth, in the cold silence of L2, the James Webb Space Telescope continues to listen. Each second, it gathers light older than memory, transforming emptiness into meaning. It is not seeking glory nor discovery. It simply observes, patient, steady, eternal, waiting for the universe to whisper again. There is a number that keeps returning in the story of K208b, a quiet constant woven through the data like a hidden melody, 120 degrees Fahrenheit. It hums in the background of every graph, every spectral reading, as though the planet itself were whispering the same word again and again, warmth. To most people, that number might not sound remarkable. It is the heat of a summer afternoon in the desert, the kind that makes air shimmer above the sand. Yet in the language of life, it may be the most beautiful temperature in the universe. At that level of heat, water remains free. It flows, swirls, dissolves, carries. Below it, molecules stiffen into silence. Above it, they collapse under the weight of their own energy. But at this point, neither boiling nor frozen, chemistry comes alive. Bonds form, break, reform. Energy moves easily through liquid, stirring the ingredients that life depends upon. On Earth, this balance allowed the first cells to breathe, to divide, to begin the slow dance of evolution. On K218b, the same warmth stretches across an entire world. The planet's thick hydrogen atmosphere holds that temperature with astonishing precision. It wraps the globe like a great thermal ocean, carrying heat from the starlit side into the eternal dark. Even where no sunlight reaches, the air remains gentle, steady, unchanging. The numbers from the telescope suggested that the entire planet, from cloud top to sea floor, glows at nearly the same temperature, a harmony so perfect that it almost feels designed. Scientists stared at those readings, expecting to find the usual chaos of nature, wild temperature shifts, storms, imbalance. Instead, they found calm. The surface warmth never dipped below the threshold of life, never rose high enough to destroy it. It was as if the planet had found its own rhythm and refused to leave it. The data described a kind of serenity that doesn't exist on Earth. Here we live in contrast, frost and fire, drought and flood. But there, the numbers whispered of constancy, of balance held for millions of years. To imagine a place like that is to sense the patience of the cosmos itself. On K208b, water would flow thickly through valleys of rock and gas, steaming slightly in the light of a red dwarf sun. The air, rich with hydrogen, would scatter light differently, turning the sky into shades of rose and copper. Clouds would drift like sheets of silk across the horizon, carrying fine droplets that fall as warm rain into oceans glowing softly from below. Each wave might move with the weight of honey, heavy yet calm, illuminated by the slow reflection of a star that never blazes, only hums. At 120 degrees, life doesn't fight for survival. It thrives. Proteins fold easily, membranes stay supple. The spark of metabolism, that delicate balance between order and chaos, burns at its brightest. Chemical reactions happen faster, energy passes smoothly from one molecule to the next, and organic matter begins to shape itself into complexity. Every degree matters, every vibration adds to the rhythm. Life loves warmth, but not too much of it. It loves motion, but not destruction. Earth knows this balance too, though it rarely holds it for long. The sun rises and falls, ice forms and melts, seasons chase one another endlessly. K218b seems to have escaped that restlessness. Its slow orbit, its stable star, its heavy air, together they create a place where time itself might feel slower. The warmth doesn't fade with the setting sun. It lingers, endless and tender, like the memory of light that refuses to die. Some scientists began to call this the cosmic temperature, a point of equilibrium written not just in K208b, but across the universe. When they studied other worlds with similar chemistry, they noticed the same threshold reappearing, the same narrow range where water stays liquid, where life might arise. It suggested something profound, that life does not need to be invented each time, but simply awakened whenever conditions reach this perfect heat. The telescope's readings captured more than temperature. They captured emotion. To those who looked at the data long enough, it began to feel like the pulse of something alive. That steady 120 degrees Fahrenheit was not static. It oscillated slightly, breathing in small rhythms, as though the planet itself were exhaling energy, a sign of deep convection within its oceans and clouds. Some nights, when scientists watched the simulations replay across their screens, they described it as listening to the planet dream. In the depths of K208b's oceans, the warmth would shape everything. Water near the surface would ripple gently, almost glowing under the muted sun. Deeper down, the pressure would compress hydrogen into dense layers, turning the ocean into a gradient of temperature and texture. At certain depths, heat would meet minerals, triggering chemical reactions that produce energy without sunlight. On Earth, that's how life began, in darkness, around vents that breathe warmth into water. It's possible that K218b holds billions of such vents, scattered across a world where the ocean never cools. That same heat would touch the air above, rising in currents that create soft winds. The sky would be filled with motion, but no violence. Lightning would be rare, thunder non-existent. Instead, light might shimmer faintly in upper clouds where hydrogen interacts with trace gases, creating colors invisible to the human eye, but detectable by Webb's golden mirrors. Each of those colors corresponds to temperature, to movement, to the subtle language of balance that defines the planet. For those who studied it, the discovery of this thermal harmony carried a quiet shock. It challenged the idea that Earth was the gold standard for habitability. Here was a world with stronger gravity, a thicker atmosphere, a dimmer star, yet its conditions were not only livable, they were ideal. It was as if nature, unbound by our expectations, had found a way to create a more peaceful version of life's home. The 120 degrees Fahrenheit mark became a symbol. Scientists began to refer to it as the breathing point, the line between chemistry and biology. It reminded them that life isn't an accident of place, but a consequence of balance. Wherever heat lingers at just the right intensity, life seems inevitable. The same temperature that makes us sweat under the desert sun might be the heartbeat of alien oceans. At conferences, when researchers spoke of K208b, they often paused before saying the number, as though it held sacred weight. 120 degrees Fahrenheit. Not too hot, not too cold, the middle ground between silence and song. It became a mantra of sorts, a quiet acknowledgement that the laws of physics are also the poetry of existence. Somewhere in that distant system, the temperature holds steady still. The air moves softly, the oceans glow, the balance endures. Light from its red star continues to fall across its surface, filtered through clouds that never let it fade too harshly. Everything there seems tuned to sustain, not destroy. In that warmth, we see something deeply familiar. It reminds us of the way sunlight feels on skin, the way water ripples under summer heat, the comfort of stability in a chaotic universe. K218b's temperature is not just a number. It's a message, a quiet proof that life thrives not in extremes, but in harmony. The telescope can't see its beaches or its rain, can't feel the heat that radiates across its sky. Yet through data alone, we understand its essence. A world that has found peace in balance. A planet that hums softly at the exact temperature where existence becomes effortless. The scientists who read those numbers often speak in hushed tones, not because they fear disbelief, but because they sense reverence. They are witnessing something sacred, not divine but natural. A demonstration that life is not rare, only waiting for the right warmth to awaken. And so the number remains, glowing in the data like a promise. 120 degrees Fahrenheit, the temperature of comfort, of persistence, of creation. Across light years, it echoes through the silence, reminding us that somewhere, far away, an entire planet may be breathing at the same warmth that sustains us here. In the story of K28b, it is not the oceans or the gases that move us most. It is this perfect, patient heat, a golden balance between chaos and calm that feels almost human. The scientists who study it call it equilibrium. The poets among them call it life's gentle fire. And as the numbers settle, the warmth remains constant, steady, alive. Yet hidden beneath that perfect calm, something else stirs, another clue waiting to be found, a new signal flickering through the data, belonging to a gas that will soon astonish the world. In the story of K2 and 8b, one discovery folds quietly into another. After the soft echo of that perfect warmth, 120 degrees Fahrenheit, another signal began to rise from the data, steady yet mysterious. It was faint at first, a thin vibration across the telescope's sensors, like a note half buried beneath noise. But as more readings arrived, the pattern grew stronger, unmistakable. Methane. To most, methane is an ordinary gas, something we know from farm fields, from volcanoes, from the fires of industry. On Earth, it has a simple reputation, a product of decay, a fuel for flames. Yet within the context of distant worlds, methane becomes something else entirely. It is a breath, a sign that something, somewhere, is alive enough to change its own sky. The scientists stared at the numbers, unsure at first. Methane can come from rock, from heat, from chemical reactions buried deep in crusts of metal and stone. But the levels detected in K218b's atmosphere were far beyond what geology alone could explain. The planet's surface, as far as they could model it, didn't have the conditions to create that much gas through natural mineral activity. There was too much of it, and it was too fresh. The molecules had to be constantly replenished, continuously made anew. Otherwise, radiation from the star would have broken them apart long ago. Something down there, or within that thick swirling air, was producing methane in real time. The realization came slowly, like dawn. On Earth, the vast majority of methane comes from life, from microbes in the ocean, from wetlands, from the bellies of animals that digest and breathe. It rises invisibly from the soil, drifts through the wind, and escapes into the sky as a byproduct of metabolism. Every puff of methane on our planet is, in a way, an exhale of life. To see it shining from across light years was like watching another world inhale. Methane is a fragile molecule. It doesn't last long in sunlight, especially under the glare of a nearby star. On K2 and 8b, the red dwarf above would have burned it away quickly. For it to remain in such abundance, something must be restoring it constantly. The simplest explanation, the one that feels almost impossible, yet strangely inevitable, is biology. Something microscopic, thriving quietly in the hydrogen seas or drifting through the thick air, might be breathing methane into the sky the way trees on Earth release oxygen. For days after the data appeared, the scientists hardly slept. They reran models, adjusted for atmospheric pressure, recalculated stellar radiation, searched for chemical pathways that could mimic life's work. Every alternate explanation collapsed under its own weight. The equilibrium of gases didn't match a lifeless system. Instead, it looked alive, self-correcting, balanced by cycles too intricate to be random. Methane, in this case, was not just a byproduct. It was a signature, a quiet declaration that energy was being exchanged, that matter was moving through living processes. On K2-8b, hydrogen and methane could form the twin pillars of a new kind of biology, one that breathes differently from anything we know. Instead of oxygen feeding its fires, this life might draw in hydrogen, combine it with carbon, and release methane back into the air as waste. The entire planet could be covered in invisible ecosystems powered by chemistry rather than sunlight. The scientists began to call it the mirror breath. On Earth, animals take in oxygen and release carbon dioxide. Plants do the opposite, creating balance. But on this distant world, everything might be inverted. The sky itself could be alive, every cloud a drifting ocean of microorganisms feeding on the warmth of their red sun. Somewhere deep in the hydrogen oceans, colonies of living matter might exist, feeding, dividing, releasing gas that drifts upward like bubbles of light. In the quiet moments of study, the data began to feel personal. Methane, once dismissed as a simple chemical, now read like a message written in the language of breath. It didn't come with sound or light, yet it carried the same intimacy as an exhale across an impossible distance. It said, "Something is here." There is a strange tenderness in the thought of an alien organism taking in hydrogen the way we take in air, drifting through a sea so thick that light moves slowly through it. The temperatures would be warm, the pressure immense. Yet within that vast weight, tiny structures could thrive, fragile, persistent, unbothered by the silence above. Perhaps they don't even perceive their own existence as separate from the ocean. Perhaps they are the ocean, living and dying within a single planetary heartbeat. To some, the methane signature was the final proof. To others, it was just the beginning of a deeper question, not whether life exists, but how different it could be. We tend to imagine aliens as variations of ourselves, creatures that need air, water, sunlight. But K218b suggests that life might not need any of those things. It might thrive in chemical gradients rather than light, finding nourishment in reactions that to us would seem poisonous. On such a planet, oxygen would be deadly, sunlight too sharp. The biology there could be soft, luminous, slow, an ecosystem built not on speed or sight, but on patience and chemistry. In the simulations, when scientists recreated K218b's environment, the chemistry behaved almost poetically. Methane rose through hydrogen-rich air, met faint traces of carbon dioxide, then returned again through chemical loops that seemed too symmetrical to be accidental. It looked like metabolism scaled to planetary size, a breathing system that covered continents and oceans alike. As they watched these virtual recreations, some scientists spoke quietly, describing the atmosphere as a single organism. The entire planet could be alive, not through individual beings, but as one continuous field of reaction and renewal. The methane would move through it like blood, carrying carbon the way oxygen moves through ours. The presence of methane also meant light might behave differently there. The air could glow faintly in the infrared, giving the night side of the planet a soft inner luminescence. Through the eyes of the James Webb Telescope, this would appear as a thin halo, a breathing layer of warmth. It was this glow that first caught the telescope's attention, a shimmer at the edge of darkness that refused to fade. Every time the planet passed in front of its star, that shimmer deepened. The same methane signature returned again and again, consistent, rhythmic. It became clear that this was not a passing anomaly. The planet was exhaling in regular cycles, the way lungs expand and contract. It was as though K208b itself was alive, not just a host for life, but a participant in it. Over time, as the data continued to arrive, the methane readings began to feel like the faint echo of breathing. On the graphs, each spike and dip formed patterns that looked eerily biological. The scientists hesitated to say it aloud, wary of overreach, but everyone felt it. This was not randomness. It was repetition. It was rhythm. One researcher described it best in a late-night interview. He said, "It's like listening to a heartbeat from another world. You can't see the heart, you can't touch it, but you know it's there because you can feel its rhythm in the numbers." In that moment, methane stopped being a chemical and became something else, a connection. The gas that once smelled of decay and industry became a bridge between worlds, proof that life does not belong to Earth alone. As data poured in, the implications grew heavier. Methane was no longer just an atmospheric trace, it was the planet's language. Its persistence told of balance, its renewal told of energy. The planet was not merely existing, it was participating in the ongoing act of creation that life always is. Scientists began to speak less about discovery and more about conversation. They said Webb was not just observing K28b, but listening to it. In the soft hum of infrared light, in the delicate dance of molecules across 1 billion miles, something was speaking back. The methane wasn't just evidence of biology. It was the breath of an entire ecosystem, one so unlike our own that even its silence sounded alive. It was proof that the universe doesn't repeat itself, that life in every corner finds its own way to say, "I am here." And somewhere in that quiet glow, beyond the reach of our words, another kind of life continues to breathe, exhaling methane into the dark, marking its presence not with noise or light, but with balance. An invisible rhythm that crosses the void, reminding us that existence itself, in every form, is a conversation between matter, heat, and time. The scientists called it a secondary clue, but it was anything but small. The methane signature was the planet's quiet confession, its softest truth, a world alive enough to breathe. Yet as the instruments continued to listen, they began to sense something even stranger, a world whose biology might be built not just from ocean or air, but from elements that twist the very definition of life. A world whose ecosystem, vast and alien, could exist in forms beyond imagination. Beneath the pale rose sky of K218b lies a realm that no light can fully touch. It is not an ocean in the way Earth knows oceans, restless blue expanses capped with foam, but something far deeper, heavier, and stranger. The scientists call it a hydrogen ocean, though that name hardly captures its complexity. It is both liquid and vapor, both water and gas, both familiar and alien. The boundary between air and sea blurs into mist, a shimmering veil where molecules drift freely from one state to another, never deciding whether they belong to sky or depth. At those pressures, hydrogen does not behave as it does here. It becomes denser, almost alive with motion, wrapping itself around water molecules to form a fluid richer than any chemistry on Earth. Within that liquid, energy moves like breath. Every atom vibrates slightly faster. Every reaction carries an echo of warmth. The ocean hums, not audibly, but in the slow rhythm of molecular exchange, a continuous flow of charge and motion that may well be the pulse of the planet itself. Scientists studying the data from K218b describe the hydrogen sea as a living laboratory. Its chemistry is unlike anything in our world. Where our oceans are ruled by oxygen and salt, this one is dominated by hydrogen bonds that create structures both delicate and unpredictable. Pressure keeps the liquid stable, allowing it to remain fluid across an impossible range of temperatures. In such an environment, life would not cling to fragile edges. It would drift, weightless, within an endless gradient of warmth and depth. Deep below the clouded surface, light would fade quickly, replaced by a glow that seems to come from within the liquid itself. Hydrogen, excited by trace minerals or internal heat, emits a faint silver luminescence. It paints the depths in a soft gleam, so that every current, every wave, looks alive with reflected fire. Some scientists think this glow could power photosynthesis-like processes, not based on sunlight, but on chemical energy carried through the fluid, a kind of internal starlight that never fades. In such a sea, creatures, if they exist, might not resemble anything with form or bone. They could be translucent, their outlines blurred by the refractive play of dense hydrogen. Their tissues might be lighter than water yet heavier than air, perfectly balanced in the pressure that fills every corner of their world. They would not need lungs or gills. Breathing would happen across their entire surface as hydrogen and trace gases flow in and out of their cells. Motion might be silent, driven not by muscle but by gentle chemical propulsion, small differences in temperature and density pushing them through the water like drifting spirits. The idea of such life is not just fantasy. The chemistry makes sense. On Earth, certain microbes already use hydrogen as fuel, drawing energy from reactions that occur far below the sunlight's reach. On K218b, that principle could scale upward into an entire biosphere, one that doesn't rely on photosynthesis, but on thermochemical balance. Life would not need to see. It would feel, react, pulse. In the absence of sight, existence there might be defined by touch and resonance, the soft vibration of pressure waves moving through liquid, the quiet hum of molecules colliding in rhythm. Above this ocean, the hydrogen atmosphere acts like a lid, sealing the energy within. The weight of that air presses down, keeping the seas from boiling away into space. The balance between pressure and heat creates a feedback loop. The ocean stabilizes the sky, while the sky shelters the ocean from radiation. The planet becomes a single self-contained system, air feeding water, water feeding air, each layer breathing through the other in perfect synchronization. To understand it, scientists often speak in metaphors. One described K218b as a planet turned inward, a world where energy circulates not from a bright sun above, but from deep chemical tides below. Another called it a heartbeat wrapped in water. The metaphor feels right. The hydrogen sea doesn't just exist. It regulates. It takes in heat from the red dwarf's dim glow, redistributes it evenly across the planet, then releases it slowly back into the atmosphere. Nothing is wasted. Nothing escapes too quickly. The system breathes, slowly, endlessly. In this world of dense air and heavy sea, storms would form differently. They would move not with thunder and lightning, but with soft spirals of pressure and temperature. A storm on K218b might rise like a slow dance, its center glowing faintly as the hydrogen within warms, expands, and rises. From space, it would look like a swirling pearl, its edges blurring into the planet's haze. These movements, while gentle by our standards, could last for centuries. Nothing on K218b happens quickly. The planet's rotation is slow, its winds steady, its chemistry patient. Within that calm, something extraordinary might emerge. The hydrogen sea, constantly cycling gases between surface and depth, becomes a kind of planetary lung. Each movement of heat carries molecules upward. Each wave that breaks returns them downward again. Through this endless rhythm, elements mix, combine, separate. The same dance that sustains life here, magnified to global scale. It is not impossible to imagine that such motion has been occurring for billions of years, uninterrupted, building layer upon layer of complexity until life, in some form, appeared naturally. The creatures of such a world would be invisible to us, not because they hide, but because our eyes cannot see what hydrogen hides. Light scatters differently there. Our telescopes can detect the chemistry of the atmosphere, but not the shimmer of the living that might drift beneath. Even the James Webb Telescope, with its golden precision, can only sense their presence indirectly, through the gases they exhale, through the balance they maintain without knowing it. To Webb, the entire planet breathes as one organism, its oceans and sky indistinguishable from the life that sustains them. At night, though night is eternal on one side, the surface of the hydrogen ocean might glow softly, reflecting the star's faint light like a mirror stretched across infinity. From orbit, it would look like a slow heartbeat of silver and rose, each pulse of brightness a reminder that motion never stops there. The ocean keeps the atmosphere alive, while the atmosphere keeps the ocean warm. It is a partnership older than memory, a harmony that seems almost deliberate. What strikes scientists most is how complete the cycle appears to be. On Earth, systems compete. Oceans lose water to the sky, winds fight against gravity, heat escapes into space. On K28b, nothing seems to struggle. Every part of the planet works in collaboration with every other. The hydrogen sea absorbs, balances, releases, while the atmosphere returns the favor in kind. It is less like geology and more like biology, a system that doesn't just exist but adapts. For those studying it, the realization feels profound. The ocean is not just a habitat, it is the planet's consciousness, its circulatory system, its skin. Through it, K28b regulates itself, heals itself, remembers its balance. Some scientists speculate that the hydrogen sea may even have layers that act like memory, chemical gradients that store patterns of reaction, passing information from one tide to the next. Such a mechanism would be primitive, but it hints at something larger. A planet capable of learning, in its own chemical way, how to keep itself alive. When people speak of K218b now, they no longer call it simply a planet. They call it a system of continuity, a world that does not separate life from environment. The hydrogen ocean and the atmosphere are one. Their connection so complete that removing one would collapse the other. In that sense, K28b is not a place where life lives. It is life itself. From our distant vantage point, we can only watch, listen, and interpret the faint whispers that reach us across space. But even in those whispers, there is music, the rhythm of balance, the sound of a world sustaining itself with effortless grace. The hydrogen ocean carries that rhythm, steady as a heartbeat, endless as time. For the scientists who study it, that realization changes everything. Life, it seems, is not confined to sunlight or carbon or oxygen. It can be born from pressure, thrive in gas, evolve in liquid fire. It can glow where darkness reigns and breathe in an ocean made not of water but of hydrogen. K218b reminds us that the universe does not imitate Earth, it invents endlessly. Its oceans are not blue, its rain does not cool, its air would crush us in an instant. Yet within that strangeness lies a quiet perfection. The planet moves through the dark like a dream, breathing through its hydrogen seas, keeping its balance as it has for ages. The James Webb Telescope watches from afar, capturing the faintest traces of that living equilibrium. Each data stream feels like a whisper from the deep, a signal not of technology, but of nature at peace. Somewhere in those silver oceans, in the gentle weight of hydrogen, the oldest story in the universe continues. The story of energy seeking form, of life finding its rhythm, of a planet alive in every molecule. And far above that endless sea, in the thick air where water becomes light, something unexpected begins to form. a strange glittering phenomenon that will soon astonish even the scientists who thought they had already seen everything K218b could offer. High above the slow, gleaming oceans of K218b, the air grows thick enough to shimmer. The higher one goes, the more unreal the world becomes. Pressure and temperature play against each other like two steady hands shaping glass. Hydrogen dominates, soft and weightless, wrapping every other molecule in its invisible warmth. Methane drifts through it like blue smoke. Carbon dioxide adds a faint heaviness. Helium dances in the upper haze, scattering light so that the sky turns a pale violet when the red dwarf's glow filters through. It is in this suspended silence that something miraculous happens, something that defies both reason and expectation. Within the upper atmosphere, the chemistry turns sculptor. Methane, under the immense pressure of thousands of layers of air, begins to fracture. The hydrogen separates from carbon, freeing the atoms to drift into new patterns. At those heights, where the heat is fierce yet contained, the freed carbon doesn't remain dust or soot. It binds again, tighter this time, in the form of crystal, tiny diamonds, millions of them. Born in clouds of methane, falling softly through an ocean of gas. The process begins invisibly, within small eddies where pressure spikes momentarily. Carbon rearranges itself in a flash like a thought made solid. These seeds then gather mass as they fall, layer upon layer of crystal forming around them, until each becomes a fragment of light too heavy to float. They begin their descent, slow at first, then accelerating as the atmosphere thickens. From above, it would look like rain, but to anyone watching from below, it would look like the sky shedding stars. On K218b, the rain never truly ends. Every few hours, pressure waves ripple through the upper air, releasing cascades of diamond dust that glimmer as they fall through the haze. The friction of descent charges them with faint static, so they glow faintly, not bright like lightning, but with a quiet pulse, as if the planet itself were breathing light into its sky. For the scientists studying these layers, the phenomenon was almost impossible to process. On Earth, diamonds are symbols of permanence, born from the deepest crust, requiring unimaginable pressure over eons. But here, they are fleeting, created, dissolved, and reborn in a cycle that never stops. The diamonds that fall today may melt back into methane tomorrow, their atoms reused endlessly in the planet's atmospheric chemistry. It is a loop of creation that mirrors life itself, constant transformation, no beginning, no end. At certain altitudes, the temperature drops just enough for the diamonds to slow their fall, suspended briefly in dense hydrogen like dust in sunlight. They catch the dim glow of the red dwarf star, scattering it into soft halos. The result is a luminous belt around the planet, a band of light that shimmers faintly even on the dark side. The glow is not fire or reflection, but refraction. Starlight passing through a billion tiny crystals before vanishing again into shadow. This halo of diamond rain acts like a filter. It absorbs harmful radiation from the star and releases it as harmless heat. The living world below, whatever forms it might take, never sees the deadly bursts that occasionally flare from the red dwarf. They are caught and softened by the rain. In this way, the diamond clouds are not merely decoration, they are protection, the planet's natural armor. Some scientists call this the veil of life, a shimmering defense woven by chemistry. In every sense, K28b seems designed to endure. Its hydrogen sea moderates heat. Its atmosphere shields against radiation. Its rain transforms danger into light. It is not chaotic or fragile, but elegantly balanced, an ecosystem built on the physics of beauty. Within that endless descent of diamonds, new mysteries emerge. Each crystal, in its fall, becomes a tiny lab of its own. As it passes through different layers of air, it collects trace gases, molecules that might combine briefly before the diamond evaporates deeper below. The process could serve as a mechanism of exchange, carrying elements from one altitude to another, feeding reactions that sustain the planet's chemistry. The rain is not only beautiful, it is functional. It is the sky's way of stirring itself. The atmosphere of K218b moves in gradients. Methane thickens as one descends, hydrogen grows denser, carbon dioxide forms ribbons that twist through the air like invisible rivers. Helium fills the gaps, creating buoyant currents that push the diamond rain sideways before it sinks again. The entire system feels alive, like lungs in motion, drawing in gases, releasing others, keeping balance through perpetual breath. The light on such a world would be like nothing we know. Under the red dwarf's muted glow, the diamond storm refracts the spectrum into ghostly colors. Blues turn violet, reds deep into bronze, gold hides in the mist. At dusk, though dusk there lasts forever, the sky would glitter with falling prisms, each a fragment of light descending through silence. The sight would be haunting, jewels cascading through endless air, never reaching the ground, dissolving into vapor before they touch the hydrogen ocean below. If life exists in the sea beneath, it would see the rain as a pulse of brightness from above, a shimmer that filters down like moonlight through clouds. For them, this light might be the rhythm of time, the signal of change. The rain falls, the glow fades, the ocean responds. Energy moves through the layers, gentle but constant. Scientists studying the planet began to wonder whether such an environment could shape evolution differently. On Earth, life grows toward light, reaching for the sun. On K218b, the light falls from above in soft bursts, never too strong, never too weak. Perhaps life there doesn't need to reach upward at all. It simply waits, floating in its warm sea, absorbing energy as it rains down. A slow, perpetual communion between ocean and sky. There is a quiet poetry in the idea that the planet's storms are made of gemstones. In our world, diamonds are objects of desire, symbols of wealth and permanence. On K218b, they are as common as rain. Each one exists for a moment, then vanishes, its atoms freed to shine again. It is a world where beauty is not stored but renewed, where even the hardest substance is part of a living cycle. Some researchers, reflecting on this, say K218b feels more like an idea than a place, a vision of how nature could operate when freed from scarcity. Everything there seems abundant. Light, heat, pressure, matter, all in balance, all feeding into the same quiet rhythm. The diamonds, the gases, the ocean, they coexist like parts of a single organism, each giving and taking in turn. Viewed through the lens of James Webb, the planet's glow becomes a pulse across the blackness of space. The telescope detects not the diamonds themselves, but the way their presence alters the light, scattering it, softening it, creating a faint halo around the planet's shadow. To human eyes, this halo appears like a crown of dim fire, suspended in silence. The deeper the observation goes, the more that crown seems to shimmer, as though the planet is covered in liquid light. It's easy to think of such beauty as coincidence. Yet when scientists plot the energy flows, it becomes clear that nothing here is wasted. The rain converts radiation into warmth, the gases maintain stability, the ocean below absorbs and releases energy with exquisite precision. Even chaos on K218b has purpose. The diamond rain in all its shimmering glory is not a luxury of physics, but a necessity of survival. Every storm, every fall of crystal keeps the planet's energy in check. Without it, the heat from the red dwarf might have burned away the atmosphere long ago. Instead, the rain absorbs that excess, releasing it gently as it falls. The system endures, balanced across millennia. To those who study it, the thought is humbling. A world where the sky rains diamonds is not a world of extravagance, but of discipline. A place where beauty is simply efficiency perfected. Each drop that falls is both art and function, a sign of nature finding grace in precision. If one could stand beneath that endless downpour, protected somehow from its crushing pressure, the scene would be dreamlike. Diamonds drifting through the air, glinting faintly in the dim red light, vanishing as they meet the haze below. No sound but the whisper of movement, no light but the glow of carbon reborn. The entire sky alive with motion, yet so calm it feels like prayer. On Earth, we look upward for meaning, searching stars for signs of life. On K218b, perhaps the meaning falls from above, in the form of crystal rain, pure and fleeting, carrying with it the quiet truth that beauty and survival can be one and the same. The James Webb Telescope captured only a fraction of that brilliance, a soft echo of light across 120 light years. Yet even that was enough to suggest something more profound. The planet doesn't just host life, it embodies it from its glowing seas to its diamond storms. Every drop, every shimmer, every particle participates in the act of living. And somewhere within that luminous sky, amid the slow descent of glittering rain, lies the greatest revelation of all. Not that the planet is alive, but the universe itself might be learning to shine through it. As scientists continued to trace those signals, another truth began to surface. One that would change not only how we see K2 and 8b, but how we understand time itself. Because the light reaching us from that radiant world does not show what is, it shows what was. Every sparkle, every breath, every fall of diamond is a memory, a glimpse of a moment that ended 120 years ago. When light travels, it carries memory. It doesn't rush, it doesn't fade, it simply endures, holding the imprint of the world it once touched. Every beam that reaches the mirrors of the James Webb Telescope is a message written in delay, a record of something that no longer exists in the present tense. The light from K2 and 8b began its journey 120 years ago, leaving its world long before the digital age, long before satellites, long before we even dreamed of machines like Webb. The image that now fills our screens is not what is, but what was. When those photons slipped free from the haze of that alien sky, our own world was cloaked in smoke from the first generation of factories. The Eiffel Tower was still new, electricity was a novelty, radio waves had only just begun to whisper through the air. Humanity's voice had not yet reached beyond its own planet, yet the light of another was already on its way, crossing the void in silence. It traveled through the dark, unbothered by time, brushing past dust clouds, grazing the gravity of invisible stars, never slowing, never aging, until at last it struck gold, the gold-plated mirrors of the telescope suspended 1,000,000 miles from home. In that instant, the present met the past. The reflection that appeared on our screens was the echo of a century gone. The methane, the glow, the diamond rain, all of it belonged to a moment older than anyone alive. The world we now call K218b might have changed 1,000 times since then, its storms drifting, its life evolving, its chemistry rewriting itself in new forms. Yet we see it only as it once was, locked in an image of light that outlasted the moment it captured. There is a quiet strangeness in realizing that every discovery Webb makes is a journey backward. The telescope doesn't show us the universe as it is, but as it used to be, a vast archive of what once breathed, once burned, once shone. When we look at K2 and 8b, we are peering through a window not just in space, but in time. We are witnesses to a planet that existed when our own species was still struggling to light the night. For scientists, this perspective alters everything. The methane we see today may already be gone. The hydrogen oceans may have thickened, the diamond rain may have slowed, the star may have flared brighter, transforming its world in ways we can't yet imagine. Or perhaps, beneath that same sky, life has continued to thrive, unaware that somewhere across the cosmos, another civilization is watching its ancient reflection. The thought unsettles and comforts at once, because the laws of symmetry in light mean that the exchange could go both ways. If a civilization exists on K208b, gazing upward through their thick violet sky with instruments of their own, their telescopes would also capture a world 120 years in their past. The Earth they'd see would not be our present, not cities glowing from orbit, not satellites tracing lines across the night, but a quieter planet, blue and green and simple. They would see steamships instead of rockets, horse-drawn carts instead of cars, a civilization barely touching the edges of electricity. They would see us in our innocence, still unaware of the cosmos that now connects us. It's a humbling symmetry. Each side sees the other as it used to be, not as it is. Two worlds staring into mirrors of time, each unknowingly looking backward across the same span of light years. Communication is impossible, yet connection exists, not through voice or technology, but through the persistence of light itself. The shared silence becomes a dialogue. When Webb's instruments translated that ancient glow into spectra, the scientists in Cambridge sat still for a long while. The graphs showed the fingerprints of methane, hydrogen, and dimethyl sulfide, but behind the data was something harder to describe, a sense of presence. It felt as though the planet itself had spoken, softly, across a century of emptiness. The message was not in language, but in persistence. It said, "I was here." Light, in its infinite patience, is the only thing that truly transcends death. It outlives the moment it was born, carrying memory across time until someone, somewhere, is ready to receive it. That is what the Webb telescope does. It doesn't just look outward, it listens backward. Every signal is an echo, every discovery a recovery of something long gone, yet still alive in light. There's poetry in the idea that while we peer into the past of K218b, the beings there, if they exist, might be doing the same. They might be looking toward the faint glimmer of our sun, detecting oxygen in our atmosphere, perhaps wondering whether that blue planet holds life. To them, our world would appear younger, full of smoke and noise, a species just beginning to tinker with industry. They would not yet see our satellites, our telescopes, or the spacecraft that now listens to them. We are invisible to each other's present, bound instead by the memory of our pasts. The light between us forms a bridge neither civilization can cross, but both can feel. It is a meeting without words, a conversation without sound. Time becomes the medium, and distance becomes meaning. Across those 120 light years, two worlds reflect one another not as they are, but as they were, frozen in mutual nostalgia. For the scientists on Earth, this realization gives the data a new weight. The 99.7% certainty of life no longer feels like a number, but like a photograph, a portrait taken a century too late. It reminds them that discovery is not possession. We have not found K218b as it is. We have only uncovered a memory of its light. What we study is its ghost, a reflection of what once was, lingering in space until the right instrument was built to receive it. That realization changes the tone of the entire mission. The James Webb Telescope is no longer just a tool for exploration. It is a time traveler. Every photon it collects is a letter from the past, a message that waited patiently in the dark until we learned how to read it. The universe, it seems, has been speaking all along. We just needed to listen with instruments quiet enough to hear. There's something deeply human in the way we respond to that. We are drawn to light, not just because it shows us what's out there, but because it carries proof that time can be touched, however briefly. To look at K208b is to feel history collapsing into the present, to see the living memory of another world suspended before our eyes. In the control room, when the first composite image of K218b appeared, someone whispered, "We're seeing their past." Another replied, almost without thinking, "Then they must be seeing ours." The thought lingered in the silence that followed. For a moment, the monitors, the data, the endless math all fell away, leaving only a shared awareness that two worlds were, in some small way, aware of each other, through the simple act of shining. If communication ever did occur, it wouldn't be in real time. The exchange would take centuries. A question asked in one age, an answer returned long after the askers were gone. Yet perhaps that is the point. The universe does not hurry. It teaches patience through distance, humility through delay. The light we see today from K218b began its journey before we could even imagine such a telescope, and yet it arrived exactly when we were ready to see it. The stars do not rush to reveal their secrets. They wait. They let time stretch until curiosity matures into understanding. In that sense, K218b is not just a discovery. It's a mirror of our own journey. We built a machine to look into the dark, and what it showed us was a reflection of ourselves. A civilization learning too late that light is memory, and memory is all we ever really have. Somewhere out there, perhaps, under that diamond sky, another kind of life is doing the same. Looking up, studying their red sun, catching the faint glimmer of a distant blue world, wondering who might be watching back. They don't know it yet, but they already have their answer. It arrived 120 years ago in the form of light that left our world, carrying with it the trace of water, the whisper of oxygen, the heartbeat of a civilization just beginning to dream of the stars. Two planets, each seeing the other through time, each unknowingly gazing upon the past of the other, connected not by proximity, but by patience. A meeting across centuries, conducted in silence, written in light. And while that connection alone would be enough to reshape everything we believe about isolation, the James Webb Telescope had already turned its gaze elsewhere, deeper into the dark, where another anomaly had begun to flicker. A new signal from a world still forming, hidden within the dust of a young star, the next secret waiting to be found. Far beyond the quiet light of K28b, deeper in the map of stars that the James Webb Space Telescope has unfolded, lies a place where creation itself is happening in real time, a cradle of dust, fire, and gravity. It is called CE Antel, a young system still wrapped in the remnants of its birth, its star glowing with the soft orange light of youth. Around it swirls a wide, glittering disk, a veil of rock, ice, and cosmic ash, all caught in the slow dance of formation. To the untrained eye, it looks like chaos. To Webb, it looks like the beginning of a world. When the first infrared images of CE-Antel arrived, scientists noticed something strange. In the smooth disk of dust circling the star, there was an absence, a dark hollow carved cleanly through the glowing mist. It wasn't a glitch, nor an artifact of distance. It was a gap, wide and deliberate, as though something had swept its hand through the dust, gathering it inward. That void was the signature they had been waiting for. It meant that a planet was there, unseen but undeniably present, shaping its surroundings like a sculptor hidden behind his curtain. The discovery was subtle, yet staggering. Until that moment, most known exoplanets had been detected indirectly, through the slight dimming of their stars or the trembling of their orbits. But CE-Antel's child world was different. It wasn't simply found, it was witnessed in the act of becoming. The gap in the dust wasn't absence, it was movement. Material from the disk was spiraling inward toward an invisible center, vanishing into the gravitational pull of a newborn planet. In that hollow space, a world was feeding, swallowing light and matter alike, growing heavier by the day. Its temperature, astonishingly, matched that of K218b, around 120 degrees Fahrenheit, a coincidence so poetic that the scientists fell silent before it. The same warmth that sustained potential life on one world was now breathing existence into another. It was as though the universe, in its quiet symmetry, had chosen a familiar temperature to weave its next experiment in creation. The planet, still nameless, is young, perhaps 6 million years old, a heartbeat in cosmic time. At that age, worlds are not yet stable. They pulse with energy, their surfaces molten, their atmospheres raw. Gases swirl in chaotic layers, crusts shift, cores ignite. To observe such a moment is like catching a flame the instant it sparks, fleeting, luminous, impossible to hold. Yet Webb, with its golden mirrors and infinite patience, caught it anyway. The telescope's sensors detected faint infrared emissions rising from the gap. That glow was not from the star itself, but from dust heated by the forming planet as it consumed the material around it. Each particle that fell into its orbit released a whisper of warmth, a signal that traveled across light years to reach us. Layer by layer, the planet was building itself, its gravity assembling the raw ingredients of a world. It's strange to think that every solid planet, including our own, once looked like this. A child made of dust, wrapped in a blanket of chaos, cradled by a young star. The same processes that shaped the ground beneath our feet are now unfolding again in CE-Antel. To watch it through Webb is like watching our own origin replayed across the distance of time and space. The difference is that, this time, we are the witnesses. The universe has turned its lens inward, letting us see what it looks like when it begins again. In the glowing disk, traces of water vapor were detected. That alone sent ripples of awe through the scientific community. Water, in any form, means possibility. It is the great enabler, the soft hand that shapes chemistry into life. To find it here, in a region still swirling with dust and gas, suggested that even as the planet forms, the ingredients for life are already gathering. The Goldilocks zone, the delicate band around a star where liquid water can exist, passes directly through this part of the disk. It means the planet is forming not in the frozen dark or the burning glare, but in the soft middle ground where warmth and stability coexist. The scientists watching the data unfold felt a sense of tenderness that few discoveries inspire. To see life elsewhere is one thing. To see the potential for life being born is another. This was not an ancient world sending its echo through time, but a new one emerging in the present. The light Webb captured was fresh. Its photons barely 6 million years old, the youngest light we have ever studied. It had traveled only a fraction of the distance of K218b's message, yet carried the same awe, the signature of creation. As Webb continued to observe CE-Antel over the following months, the gap in the dust deepened. The newborn planet was growing hungrier, pulling in gas and debris with increasing force. The motion created spirals across the disk, long arms of material twisting like galaxies in miniature. In those spirals, the future of the system could already be read: moons forming, atmospheres condensing, orbits settling into harmony. The scene was a symphony of gravity. every particle a note, every orbit a beat. From a distance of hundreds of trillions of miles, the process looks serene, but within that calm lies unimaginable violence. Collisions happen constantly. Fragments of rock crash together at tens of thousands of miles per hour, melting into magma, reforming into larger bodies. Lightning crackles through dense clouds of dust, igniting reactions that will one day form the seeds of minerals and metals. It is both destruction and birth in one motion, the timeless rhythm of worlds in formation. For the team at the Space Telescope Science Institute, the moment felt almost sacred. To look at CE-Antel was to look at Genesis itself. Not the word, not the myth, but the act, the raw unfolding of matter into structure, chaos into form. In that glowing disk of dust, the universe was once again proving that creation is not an event, but a continuous process, always happening somewhere, always renewing itself. When they plotted the data, something unexpected appeared. The forming planet's temperature, though still high, showed fluctuations, brief drops that hinted at cooling layers of gas. It suggested that the planet's surface might already be beginning to solidify, forming the first crust over its molten heart. If that is true, it means the planet's transformation is moving faster than anyone expected. It's as though time itself has accelerated within that disk, condensing eons into moments. The poetic symmetry of it all didn't go unnoticed. K28b, a world old and alive, and CE-Antel, a world new and forming, are linked across space by the same gentle warmth, 120 degrees Fahrenheit. One perhaps holds the story of life that has already written itself. The other, the story still waiting to begin. Between them lies a bridge of time, a reminder that creation and endurance are not opposites, but reflections of the same universal impulse. When Webb turned its golden mirrors towards CE-Antel again, the images came back with faint bands of light rippling through the dust, waves spreading outward like echoes of a heartbeat. They were caused by the forming planet's gravity tugging on the surrounding material, sending rhythmic pulses through the disk. The scientists watched in silence as the data confirmed what their instincts already knew. They were not just seeing a planet form, they were witnessing its first breath. It is a strange feeling to watch a world inhale for the first time, to know that somewhere, across light years, gravity and chemistry are conspiring to create a future. A place where oceans might one day rise, where storms will carve landscapes, where perhaps someday life will take shape beneath an unfamiliar sun. CE-Antel reminds us that the story of the universe is still being written. We tend to think of it as something ancient and finished, but every new image Webb sends back says otherwise. The cosmos is alive with movement, birthing stars, weaving worlds, scattering light into new beginnings. The telescope doesn't just look into the past, it also captures the present tense of creation, the moment the universe takes a new breath. When the scientists finally stepped away from their screens, they described the feeling not as discovery, but as witnessing. They had not found something, they had seen something, the way one sees sunrise after endless night. CE-Antel was not just another coordinate in the catalog of stars. It was the living proof that the cosmos still creates, still experiments, still dreams. And in that realization came a quiet truth. The same universe that forged Earth in fire continues to forge new worlds in silence. Every gap in a disk of dust, every faint glow of heat is another promise that creation is endless, that life is not an accident, but an ongoing conversation between matter and light. As Webb's mirrors shifted to their next target, the data from CE-Antel lingered on the screens like an afterimage of birth. The gap in the dust was still there, still widening, still singing its silent song. Somewhere within that emptiness, a new world was forming. The cosmos' next line in a story that will never truly end. And for the first time, humanity was not merely imagining it. We were watching it happen. There is a quiet certainty that spreads through the scientific world after the discovery of K28b and CE-Antel. A feeling that the search has only just begun. What the James Webb Space Telescope has shown is not merely that life might exist elsewhere, but that the conditions for it are scattered across the cosmos like seeds waiting for the right warmth. The realization shifts something fundamental in humanity's perspective. We are no longer asking whether we are alone, but how many others there might be. The question is no longer existential, but logistical. In the months following the release of Webb's discoveries, the project that astronomers had long whispered about begins in earnest. It is called the Biosignature Survey, and it marks the start of a new era, an age in which the search for life is no longer poetic speculation, but structured science. The telescope, with its unblinking golden eyes, begins to map more than 200 star systems within 100 light-years of Earth, a sphere of cosmic proximity vast enough to humble the mind, yet close enough for detail. Each system is scanned for the subtle fingerprints of biology, the spectral combinations of gases, the soft irregularities in reflected light, the patterns that hint not at chaos, but at order. The survey's goal is not to catalog planets, but to trace life itself. It seeks the delicate imbalance that living systems create. Too much methane without ammonia, too much oxygen without a geological cause, the small but persistent signals of metabolism on a planetary scale. Where chemical equilibrium is broken, life has intervened. It is the same method that revealed the breadth of K218b, now expanded across 100 million billion miles of sky. From the first data streams, patterns begin to emerge. Some worlds glow faintly in the infrared, their atmospheres thick with water vapor. Others carry traces of carbon compounds that hint at photosynthetic chemistry. Each one is different, yet all seem to follow a strange symmetry, a narrow band of temperature, a balance of gases, a whisper of movement that falls within the same range of possibility. The universe, it seems, favors life where conditions allow. It doesn't sprinkle it randomly. It repeats it, methodically, across the spiral arms of the galaxy. The Biosignature Survey is designed to last decades. Webb, though its time is limited, serves as the first handoff in a chain of successors. Ground-based observatories like the extremely large telescope and the 30-meter telescope are being prepared to take its data and magnify it. These will be followed by orbital giants not yet launched, telescopes that will use light not just to see, but to analyze the faintest chemical exhalations from alien skies. Each generation will inherit the curiosity of the last, extending the reach of our senses farther into the void. But the next stage of the search moves beyond biology. Once the Biosignature Survey has charted which worlds breathe, the next question becomes, which ones think? This is where technosignature exploration begins. Instead of looking for natural gases or chemical balance, it searches for the fingerprints of intelligence, the subtle exhaust of civilization. Scientists speak of it in almost hushed tones. Technosignatures are not just signals, but stories. They could take the form of industrial gases, compounds that nature does not produce but machines do. They could appear as unnatural concentrations of heat, light, or radiation, too structured to be random. Some might even manifest as faint rhythmic glimmers across the night, the telltale signs of cities burning light into the dark. The instruments for this phase are still in development, arrays that will combine optical, radio, and infrared data into a single, seamless view. The Origin Space Telescope, proposed as Webb's spiritual heir, will be sensitive enough to detect a city's glow on a planet dozens of light-years away. The Life Finder Interferometer, a network of small telescopes operating in harmony, will look for narrow-band laser emissions, intentional signals, or perhaps the byproducts of technology so advanced that it has forgotten we might be watching. As the data accumulates, the vision expands. The plan is to create something humanity has never possessed before, a map of life, a detailed atlas of biological and technological presence across our galactic neighborhood. It will not be static, but living, updated with every observation, expanding outward with every new instrument. It will begin as a circle of light 100 light-years wide, but within decades that circle will grow. Each pinprick of possibility will be marked, cross-referenced, and observed again, not to claim ownership, but to understand the pattern. What this map will reveal, scientists believe, is not just where life is, but how it behaves across time. Whether it flourishes briefly and fades, or persists and spreads, whether intelligence is rare or inevitable. The project is less a search for neighbors and more an act of cosmic anthropology, the study of existence itself. In quiet rooms lit only by the glow of monitors, teams across the world work on algorithms capable of distinguishing the faint hum of civilization from the natural noise of stars. The process is slow, meticulous, almost meditative. Every spike in a data curve is checked, cross-checked, stripped of bias. Most are dismissed: cosmic rays, flares, distant quasars. But sometimes, just sometimes, a pattern remains. A pulse too regular to be random, a rhythm too precise to be nature alone. No one calls these discoveries proof, not yet. But the silence that follows each of those patterns is heavy with possibility. The thought that somewhere, perhaps only a few dozen light years away, another species might be conducting its own surveys, listening, recording, waiting for a signal from us, gives the search a strange intimacy. The biosignature survey becomes more than a project, it becomes a mirror. The data it returns does not just reveal the galaxy, it reflects humanity's own hunger to understand. Every system mapped, every spectral line captured, is a reminder that our desire to know is itself a form of life's persistence. We are part of the pattern we are studying. The work expands into philosophy as much as physics. Scientists begin to ask whether life is a rare accident or a fundamental property of matter. The evidence grows toward the latter. Wherever there is balance between energy and order, life seems to emerge, as though the universe prefers animation to stillness. The cosmos, seen through Webb's lens, appears not as a cold void, but as a living mosaic, self-aware through the creatures that arise within it. Funding increases, nations cooperate, and for the first time, astronomy becomes a global effort not driven by competition, but by shared curiosity. The images from Webb circulate not as data points, but as invitations, glimpses into the common story of creation. School children learn to read spectra as easily as they once learned constellations. The night sky ceases to be a mystery and becomes a map. In time, as humanity builds telescopes larger and more precise, the questions grow quieter but deeper. What happens when we finally detect not just biology, but civilization? What will we say to the light that speaks back? Will we respond or simply listen? These are not technical questions, but moral ones, the kind that define species, not just sciences. Through it all, the 120-degree worlds remain as quiet anchors, reminders of both simplicity and pattern. That temperature, recurring again and again in the data, begins to take on almost mythic meaning. Scientists call it coincidence, but poets among them whisper that it may be something more, a signature of balance written into the physics of life itself. It is the warmth of metabolism, the heat of creation, the universal comfort where chemistry becomes consciousness. As the biosignature survey continues, humanity begins to see itself differently. We are no longer the observers at the center of things, but participants in a vast, ongoing conversation. Every telescope we build, every spectrum we decode is a reply to the light that reaches us, the universe asking us to look, to listen, to recognize that we are one expression among countless others. The age of exploration has not ended. It has evolved. Ships no longer sail oceans of water, but oceans of light. We do not navigate by stars anymore. We study them, listen to them, learn from them. Each discovery becomes less about distance and more about understanding that every world, every atom, every photon is connected by the same impulse: to exist, to change, to see. When historians speak of this time, they will not call it the space age. They will call it the age of living light, the era when humanity learned to look outward and, in doing so, found itself reflected in the quiet intelligence of the cosmos. And as the data grows, a pattern begins to whisper through the numbers, subtle yet unmistakable. A rule, almost hidden, linking all the living worlds together. Not by chance, but by rhythm, as though the universe itself keeps time. The scientists do not yet understand what it means, but they can feel it forming, like a melody at the edge of hearing. Something is repeating, a symmetry, a constant, a pulse beneath the chaos, hinting that life, across all distances, might follow one universal beat. There comes a moment in every age of discovery when science begins to resemble reflection. When the farther we look into the universe, the more clearly we begin to see ourselves. The discoveries of the James Webb Space Telescope were meant to expand the boundaries of astronomy, yet what they have truly done is soften the boundary between existence and meaning. After the countless spectra, the chemical fingerprints, the light curves and calculations, one truth begins to hum quietly beneath the data. Life is not an exception. It is a language. The universe speaks it fluently. Among the billions of measurements gathered from distant worlds, one number repeats like a refrain: 120 degrees Celsius. It appears in the atmosphere of K218b, in the young heat of CE Antel, in the simulated models of other potential biospheres across light years. The figure is not exact, yet the pattern is persistent. It is the warmth of balance, the midpoint between chaos and collapse, the temperature where molecules can both bond and move. To the scientists, it begins as coincidence, then symmetry, and finally, something that feels almost deliberate. Perhaps this number is not merely a measurement, but a sign, not of design in the mystical sense, but of order arising naturally from the laws of energy. It is the point where chemistry gains rhythm, where motion becomes memory, where reaction becomes repetition. Life, it seems, prefers a certain pace, a certain pulse. Across worlds that will never meet, it chooses the same gentle warmth to awaken. The thought carries a strange comfort, that somewhere in the endless dark, creation hums to the same tune. In long nights at observatories, scientists begin to speak of it less as a statistic and more as a metaphor. They call it the universal middle, the temperature of possibility. It is not fire, not ice, but the narrow space in between, where patterns persist long enough to become stable, where stability breaks just enough to evolve. Perhaps that is what life truly is, the balancing act between stillness and motion, a cosmic equilibrium made sentient. Once, humanity believed itself to be unique, a flicker of consciousness in an indifferent cosmos. The stars were silent, the void eternal. But now, the data refuses that story. Every new observation hints that biology is not rare, but inevitable. Wherever the conditions align, the same chemistry blooms, rearranging atoms into awareness. The universe does not need miracles to create life. It only needs time. Out of the simplest laws, complexity arises like a whisper that refuses to fade. There is something deeply humbling about realizing that Earth, for all its beauty, is only one verse in an infinite song. The oceans that cradle our lives are not the only seas that shimmer under alien skies. The light that nourishes our world is not the only warmth that stirs molecules into meaning. In the grand ledger of the cosmos, we are not the beginning, only one expression among countless others. A drop in a biological ocean too vast for imagination. The philosophers who follow these discoveries begin to rewrite the old questions. The universe, they suggest, may not be a stage for life, but a participant in it. Matter, under the right conditions, seems to yearn toward awareness, as though existence itself seeks to observe. The stars give rise to planets, the planets to oceans, the oceans to thought, and thought to curiosity, which turns back to the stars. It is a perfect circle, a self-sustaining dialogue between creation and comprehension. When viewed from this distance, life no longer feels like an accident. It feels like the universe recognizing itself. Every living cell, every conscious mind, becomes a mirror reflecting back the cosmos that formed it. The atoms in our bodies are borrowed from stars. The air we breathe once belonged to explosions older than time. We are not visitors in the universe. We are its continuation, its attempt to understand its own existence. The number 120 degrees Fahrenheit becomes a symbol for that recognition. It is the temperature of transition, the precise balance where chaos organizes. It is the warmth of home, not just for us, but for everything that breathes, divides, and dreams anywhere in the cosmos. On Earth, it is the heat of a summer afternoon, of sand between fingers, of water that welcomes rather than burns. On another world, it may be the touch of hydrogen mist, the quiet cradle of an ocean unseen. Across all these distances, the temperature unites them, a quiet reminder that creation follows patterns, not whims. As the biosignature survey expands and the technosignature searches begin, the old question, "Are we alone?" loses its urgency. It feels outdated, almost small. The new question is gentler, more reflective. From how far are they seeing us now? It acknowledges connection rather than isolation. Somewhere, perhaps light years away, another civilization may be studying the same constants, decoding the same patterns, reaching the same conclusion, that life is not a visitor in the universe, but its native tongue. There's a subtle shift in how scientists talk about discovery. It stops being about finding others and becomes about recognizing the self within the larger whole. The more we study the stars, the more they begin to feel familiar, not as destinations, but as reflections. When we look outward, we are looking backward, into the time when our own atoms were still unformed dust. The universe is not separate from us. It is our ancestry written in light. The repetition of warmth, of balance, of life itself hints at something profound about existence. It suggests that the cosmos operates less like a machine and more like a mind, not thinking in words, but in patterns, rhythms, and recurrence. Every repetition of 120 degrees Fahrenheit becomes a heartbeat, every instance of biology a thought. The universe, in this view, does not simply contain life. It is alive, unfolding awareness across infinite forms. Such ideas blur the line between science and philosophy, but perhaps that is where they belong. The telescope measures light, but it also measures meaning. Each discovery pushes reason to its edge until logic begins to sound like poetry. The data is precise, but what it evokes is timeless. The feeling that to exist is to participate in something immeasurable. Even among the most pragmatic scientists, there's a quiet reverence now. The work has become less about conquest and more about communion. Each new spectrum, each new temperature reading, feels like a line of dialogue in a conversation older than stars. Humanity, through its machines and questions, has become fluent in a cosmic language, one that speaks not through noise, but through order, not through chance, but through rhythm. In the glow of the observatories, one can sense it, that shift from searching outward to listening inward. The silence of space no longer feels empty. It feels full, dense with presence. The light that reaches us carries not just information, but emotion, a calm assurance that we belong to something vast yet intimate. Perhaps that is the final lesson of this age, that meaning is not bestowed from above or hidden in mystery. It arises naturally, as life does, from the interplay of pattern and awareness. The universe does not need to answer us because in its unfolding, it already has. We are the question and the response, the observer and the observed. So when we gaze up at the night sky now, we are not asking for proof. We are acknowledging kinship. The stars do not look distant anymore. They look alive, each one a variation of the same story written in different light. And maybe, somewhere beyond K218b, beyond CE Antel, another being is doing the same, looking into the same cosmic sea, tracing the same constants, feeling the same quiet wonder. They may not know our name, our world, or our words, but they know the warmth. The same warmth that begins everything, the same temperature where chemistry starts to dream. In the end, perhaps 120 degrees Fahrenheit is not just a number, but a promise that life will always find its way to balance, that consciousness will always rise where the universe allows, that every world, in its own way, is part of the same unfolding thought. We no longer look up to ask whether anyone is out there. The light has already answered. It tells us softly, through every spectrum, every signal, every repetition of warmth, you are never alone.